All right, week 5, part 1, we're talking about hyperbolas. So the hyperbola, this is the last conic section that we will discuss. And if we were looking at, we have our cones here like this. Let's see, if we were to take a plane, this is going to be difficult, but imagine a plane slicing through. Okay, and we'd get this intersection. Maybe that makes sense. That's what we're looking at when we talk about a hyperbola. Uh-oh, out of there. All right, so the definition of a hyperbola is we have it's the set of points or the locus of points whose difference in distances to 2 points, which we call focal points, is the same. So for the ellipse, it was the exact same thing, except this was sum, meaning we were adding the distances. So here we're subtracting them. So I know this is a little confusing with all the color, but here is a focal point, and here is a focal point, okay? And so pretend that's all we have, and what we're looking at is some point, for example, this point in red, the distance to this focal point and the distance to this focal point, all right? So if this were an ellipse, we'd be adding them together, right? And the shape would look like this, but it's a hyperbola, so we're subtracting them. So D minus C is something. And if we pick any other point on the hyperbola, either side, for example over here, that will be the same amount as W minus Y. And I'm just choosing these variables so I can represent them. Pick any other point over here, for example, this point in blue. This distance, so distance of this focal point minus distance of this focal point, that will be the same. So all of these would be the same. This is sort of the definition of a hyperbola. Basically, students think it looks like two parabolas, okay? And they tend to draw them just sort of haphazardly like this. And that's close, but not correct, okay? It's not correct because you see how we have these asymptotes. So this is sort of a unique feature of the hyperbola in that it's not just some random parabola that starts curving back in. It does start getting closer and closer and closer to those asymptotes. So we'll talk about where those asymptotes come from, how to find them, and whatever. But it's not two parabolas. Okay. So equation of an ellipse, I almost said, haha. The equation of a hyperbola looks very similar to that of an ellipse. This would be plus if it were an ellipse, but if it's subtracted, we're going to end up with a hyperbola. And remember, with an ellipse, it's the sum, and with hyperbola, it's the difference. Ah, I like that. Okay, so we have x squared over a squared. So in the x direction, we're going to go a units out from the center, and those end up being our vertices. All right. And then in the subtracted term, we're going to go b units up and down in the y direction. And then so this rectangle isn't actually part of the hyperbola. The hyperbola is this. But this box, so this box and the asymptotes, we basically use to help us draw the parabola. So the box sort of frames the asymptotes, and it goes through A and B. So it's A units this way, B units this way. So we draw that box, and through the corners of the box go the asymptotes, like that. Because this is the rise over run here is B over A, we can say that the equation of this line, meaning this asymptote, is y equals B over AX. That's y equals mx plus b. Y-intercept is 0. All of these hyperbolas so far will pass through the origin. And this other asymptote would have an equation of the line that is y equals negative b over ax. See how it's passing or going downward. Okay, negative slope. So the vertices are these points, which would have coordinates like this. The asymptotes are these, which would have equations of lines, as I just explained. The focal points, all right, focal points end up being sort of outside of the diagram, okay, outside of the box. So there's a little helpful hint down here. Think outside the box to help us remember, oh, with a hyperbola, we're drawing that box and the focal points are outside it. And we find, so for an ellipse, we had c squared equals a squared minus b squared. This was for ellipse. For hyperbola, it's a squared plus b squared. Notice, ooh, this does get tricky. So that's plus, but this is minus. Okay, so that's for ellipse. I'm just comparing and contrasting. You can leave that there, or maybe you didn't write it. But anyway, this is what we use for hyperbola. All right, C is going to be greater than A, meaning C, the distance from the center to the focal point, is going to be larger than A. The focal points are outside of the box. And then the transverse axis, so this is called the transverse axis. This is the conjugate axis. I don't know if you have to know, or I don't think you have to know that, meaning we won't come across it in our book. Transverse axis, okay. We will apply this. So this hyperbola opens to the sides, okay? And notice how x was the positive term. We may also have the situation where y is the positive term and the x term is being subtracted. Notice how a is underneath the y. So a is always, I'm going to write this, a is always part of the positive term. And b is part of the negative term, or the one that's being subtracted, negative term. Okay, so in this situation, we are going to go a units up and down from the center, and that's where our vertices will be. So the positive term determines where our vertices are. These are the vertices of the hyperbola. The focal points, again, we could find from c squared equals a squared plus b squared. C will be greater than a. The focal points are farther away from the center than the vertices are. I'm going to say vertex. Hey. Vertex and vertex. All right. And then we go B to the side. We would draw the box through the corners of the box, go the asymptotes. And notice how the equations of these lines look incredibly similar, only this time the slope is A over B, rise over run, whereas over there it was B over A. So equations of lines that are our asymptotes. We have our vertices, asymptotes, focal points, and then the transverse axis again is this, and it has a length of 2a. All right, so think outside the box. If we can compare and contrast the ellipse and the hyperbola, I think it's very helpful. So the focal points of a hyperbola are outside the vertices, meaning farther from the center. Focal points for an ellipse are inside the vertices. Just for a refresher, if these are our focal points, this would be our ellipse, these would be the vertices. We'll write that F, V, and V. Okay. Good. Next page, let's practice. Spoiler alert. Alright, so please graph the hyperbola and list the details. So, first we look at the equation. We recognize, hey, this is a minus, so it's going to be a hyperbola. So this is 5 squared. We're going to go 5 up and down to find the vertices up and down because it's underneath the y. And we'll go 3 left and right from the center to finish drawing this box. And then we'll figure out all this other stuff. So let's see. Where are we? Ah, yes, here we are. So, from the center, I went up 5, and drew that. So this point right here is going to be the vertex, and then down 5, and this is the vertex, and then 3 to the left, 3 to the right, the 3 to the right, tongue twister, and then I drew the box. Okay, the box is going to help us with the asymptotes. Let's label here first, and then, sorry, so that we can label at the same time. C squared equals a squared plus b squared, so I'm solving, and c ends up being, so the square root of 34, which is about 5.8, and I needed that decimal because I needed to know where to draw it. So if we look, here's 1, 2, 3, 4, 5, and then 6 would be right here, so right here this would be our focal point. So let us label vertex and focal point, foci, And that's plural, but we're drawing two of them, so sounds good. All right, vertex and focal point, foci. All right, so we have the box now. Let's draw these asymptotes. Choose a nice color. We'll go with the orange as well, just because. So the asymptotes are going to go through the corners of the box and through the center. Very nice. Like so. Okay. And then when we draw our graph, we'll get a nice distinct color. And so the graph is going to go through the vertex and then approach the focal points. So it's going to come in like this through the vertex, not the focal point, but then get closer and closer and closer to the asymptote. Notice how it wasn't just some random parabola like this, and then I moved on to the next question. No way. And then up here, close, close, close to asymptote through the vertex, and then close, close, close to asymptote. Very nice. So that is our hyperbola. Okay, let's list this information. So the vertices are at 0, 5, and is that right? Yeah, we got a y-coordinate of 5 and 0, -5. Our asymptotes might run out of, well, whatever. Y equals, and so it looks like our slope is 5/3, so we're going to have a 5/3 x. Again, y-intercept is 0. And the other one, so y equals 5/3 x, that was this line, and then this line will have an equation, y equals -5/3 x. The focal points here and here, 0, 5.8. Let's be more specific. All right, that was a rounded answer. This is exact. So 0, square root 34 and 0, negative square root 34. And then the transverse axis, sorry that this is super messy. Transverse axis, all we're doing is saying how long is it. And so that is basically distance between the vertices, 10. All right, beautiful. So now we're going to work backwards. Please find the equation and list the details. So we were given what you have on your paper, and I did a little pre-drawing here. So we know that these are the vertices. Is that 4? What is this? What is this? Oh, good. Yeah, that's 4, 0. And there's -4, 0. And it looks like our focal points were highlighted at 5 away from the center. So that makes sense. Let's see. C squared equals A squared plus B squared. Is 5 squared equal to 4 squared plus 3 squared? You betcha. So our vertices are 4 away. B in the equation is 3 away. This is the box. These are the asymptotes. And this would be our nice hyperbola. Okay, good graph. So from this, we can determine that A equals 5. Whoops, I didn't say that. We can determine that A equals 4, and we can determine that B equals 3. And the vertices go from the center in the x direction, so 4 squared is going to be underneath the x. So our equation, let's do this. Our equation will look something like this. We're going to have x squared over 4 squared. It's a hyperbola, so minus. And we have a y squared over 3 squared equals 1. And we would simplify just a little bit to say this. Alright, so that is our equation of that hyperbola. And then we're going to just label this information, make sure we know what we're talking about. The vertices are here. So we could list those coordinates. So it doesn't get too messy, we're going to have a smaller marker. So negative 4, comma 0, and 4, comma 0. Our asymptotes, so we're talking about the equation of this line, rise over run for slope. So we would have y equals 3/4 x and y equals negative 3/4 x. Our focal points, they're listed there, negative 5, comma 0, and 5, comma 0. And the length of the transverse axis is 8. Very nice. Thanks for listening.